Hello dear students, welcome to mathematics class. This is Prakash from Tunga Degree College, Jamkhandi. In this class, we are discussing some standard results on lower Riemann sum and upper Riemann sum. So in that, the first one is, so here it is the first result. If f from the closed interval ab to the set of real numbers is a bounded function and p belongs to the partition p of the closed interval ab, then small m into b minus a is less than or equal to LPF lower Riemann sum is less than or equal to UPF upper Riemann sum is less than or equal to capital M into b minus a, where m and m, small m and capital M are the infimum and supremum of the function f on the closed interval ab. So let us prove this result. So here it is the proof. Let p is equal to a, which is equal to x0, x1, x2, so on up to xn, which is equal to b. So here it is the partition for the closed interval ab. Be a partition of AB. So this one is given here, P belongs to P of the closed interval AB, that we are considering here as P is equal to x0, x1, x2, so on up to xn, which is equal to B, means that is the upper limit of the interval AB. So it is a partition of the closed interval AB. And also it is given that since f is bounded, so here it is given that the function is bounded. So it implies that f is bounded on each sub intervals, on each sub intervals. Since f is bounded on the total interval AB, hence the same function f is bounded on each and every sub interval, which can be obtained by dividing the closed interval AB into partitions. In general, the sub interval is given by IR, which is equal to XR minus 1 comma XR, where R takes the values from 1 to n. So here it is the general representation of Rth sub interval. Next, let small mr and capital Mr be the infimum and supremum of f on IR. So let us consider small mr and capital Mr be the infimum and supremum of the function f on IR, where IR is the Rth sub interval. And also it is given that small m and capital M are infimum and supremum of f on the closed interval AB. It is given in the statement of the result. So therefore, here M is the infimum of the closed interval AB. This is the whole interval, and this interval is divided in the sub intervals, in that IR is the Rth sub interval. So here MR is the infimum for IR and M is the infimum for the closed interval AB. So by this we can write that M is less than or equal to MR, because M is the least value in the closed interval AB and MR is the least value in the Rth sub interval. So by comparing these two intervals, AB is larger, then the small m will be less than small mr, and capital Mr is less than or equal to capital M. So here capital Mr is the supremum of the function on IR and M is the supremum of F on AB. So, therefore, here it is also a supremum, here capital M is also a supremum, but on comparing AB is the larger interval than IR. So, therefore, small mr will be less than or equal to capital M. On combining these two results, we can get that M is less than or equal to mr and this mr is less than or equal to capital Mr and this is less than or equal to capital M. Now, multiplying throughout by delta R. So, therefore, we get M into delta R less than or equal to mr into delta R less than or equal to capital Mr into delta R less than or equal to M into delta R. So, here delta R is the length of Rth subinterval, it is given by xr minus 1. Now, by taking the summation over R is equal to from 1 to n, then we get summation over R is equal to 1 to m into delta R less than or equal to summation over R is equal to 1 to n mr delta R less than or equal to summation over R is equal to 1 to n capital Mr into delta R less than or equal to summation over R is equal to 1 to n capital M into delta R. And here this M is independent of R, then we can write this result as M into summation over R is equal to 1 to n delta R less than or equal to summation over R is equal to 1 to n small mr into delta R less than or equal to summation over R is equal to 1 to n capital Mr into delta R, and here summation over R is equal to 1 to n capital M into delta R. So, here this can be written as M into summation over R is equal to 1 to n delta R, since M is independent of R. Now, we know one standard result, that is the standard result is summation over R is equal to 1 to n delta R, this is nothing but B minus A. So, here it is the sum of lengths of all the subintervals, that is nothing but the length of the given interval AB, that is B minus A. Then by using this result we get M into B minus A, because summation over R equal to 1 to n delta R is equal to what? B minus A is less than or equal to. So, already we know that summation over R is equal to 1 to n small mr into delta R, where small mr is the infimum of the Rth subinterval IR. Then this can be written as LPF, lower Riemann sum, and here it is capital R mr, that is nothing but supremum of the function f on the Rth subinterval. So, therefore, that can be written as UPF by using the definition of lower Riemann sum, it is LPF, and by using upper Riemann sum, this one can be written as UPF, and this one is less than or equal to this M as it is, and summation over R is equal to 1 to n delta R can be written as B minus A. So, therefore, this one is B minus A. So, here it is the desired result, that is small m into B minus A less than or equal to LPF less than or equal to UPF less than or equal to capital M into B minus A. The next result is, if f from the closed interval AB to R is a bounded function and P belongs to P of the closed interval AB, then the first one is LPF is less than or equal to UPF, second one LP minus F is equal to minus of UPF, the third result is UP minus F is equal to minus LPF. So, here LPF means lower Riemann sum, UPF is upper Riemann sum. In LPF, here P is the partition and f is the given function, and here LP minus f is there. So, here P is the partition, and here we are using the negative of the given function. Actually, the given function is f, and here in the result it is minus f. Let us prove this one. To prove this one, again consider the partition P. Let P is equal to A, which is equal to x naught, x1, x2, so on up to xn equal to B, be any partition of the closed interval AB. Let small m and capital M be the infimum and supremum of the closed interval AB. So, here small m and capital M, these are the lower and upper bounds of the closed interval AB. So, here it is the infimum, means greatest lower bound and least upper bound of the closed interval AB, and small mr and capital Mr be the infimum and supremum of f on the rth subinterval IR, which is equal to xr minus 1 to xr. So, here we have considered that small m and capital M as the infimum and supremum of the function f on the closed interval AB, and small mr and capital Mr as the infimum and supremum of the rth subinterval IR. Now, to prove the first result, here we know that always lower bound is less than upper bound. So, here infimum is always less than or equal to supremum. By using that result, we can write that small mr is less than or equal to capital Mr, where r takes the values from 1 to n. So, it is by the result that always infimum is less than or equal to supremum. Now, multiplying this inequality by delta r, that is mr into delta r less than or equal to capital Mr into delta r. Here we know that delta r is the length of IR, that is equal to xr minus 1. Now, applying the summation over r is equal to 1 to n. So, now summation over r is equal to 1 to n, small mr delta r is less than or equal to summation over r is equal to 1 to n capital Mr delta r. And again, by using the definitions of lower Riemann sum and upper Riemann sum, we can write that here small mr is the infimum. Wherever we are using the infimum, that sum will be the lower Riemann sum, that is LPF is less than or equal to, here it is supremum, means that is the upper Riemann sum UPF. So, therefore, the first result is proved, that is LPF is less than or equal to UPF. Then let us prove the second result. It is given that f is bounded. F is bounded on the closed interval AB. Then it implies that minus f is also bounded on the interval AB. But here only the difference is whatever the upper bound of f, that becomes the lower bound of minus f, and lower bound of f becomes the upper bound of minus f, because it is the negative function of the given function f. So, therefore, small mr and capital Mr are infimum and supremum of f on IR. So, here small mr and capital Mr are the infimum and supremum of the function f on IR. So, it implies that minus capital Mr minus small mr are infimum and supremum of minus f on IR. So, here small mr is the infimum, then if you multiply that by negative sign, that becomes the minus mr, then it becomes a supremum, and minus capital Mr becomes the infimum of negative of the function f. Now, we know that L p minus f. So, here actually L p f is equal to what? Summation over r is equal to 1 to n small mr into delta r, where that small mr is the infimum of the function f. But here the function is minus f and its infimum is given by minus capital Mr. So, therefore, it becomes summation over r is equal to 1 to m minus capital Mr into delta r. So, here minus Mr is the infimum of the function minus f. So, therefore, it is the Lp minus f, means lower Riemann sum for the function minus f, and this can be written as, here the minus 1 is constant, we can take it out from the summation, then it becomes minus of summation over r is equal to 1 to n capital Mr into delta r, and here Mr is the supremum of the function f. Then by the definition of upper Riemann sum, we can consider this as minus of UPF. So, therefore, it implies that L p minus f is equal to minus of UPF. So, this is the second result, that is Lp minus f is equal to minus UPF. Then the third result is Up minus f is equal to minus Lpf. So, here the third result, here also we can consider that the same data, that is given that f is bounded on the closed interval AB, then minus f is also bounded on the closed interval AB. So, and consider small mr and capital Mr are infimum and supremum of the function f on the rth subinterval IR, then it implies that minus of capital Mr and minus of small mr are the infimum and supremum of minus f on rth subinterval IR. Now, we know that Up minus f, whenever we are considering the upper Riemann sum, then we need to consider the supremum of the function. So, here we are considering the upper Riemann sum, that is Up minus f, upper Riemann sum of the function minus f, then that is equal to summation over r is equal to 1 to n. Here the supremum of the minus f, here the supremum is minus mr. So, therefore, that is minus mr into delta r. Again that minus 1 is constant, we can take it out from the summation, then it is minus of summation over r is equal to 1 to n small mr into delta r, and already we know that small mr is the infimum of the function f on the rth subinterval, then it gives minus of LPF, because the summation over r is equal to 1 to n, mr into delta r is the lower Riemann sum of the function f in IR. So, therefore, here it is the result UP minus f is equal to minus LPF. So, these are the 3 standard results. The first one is LPF is less than or equal to UPF, and the second one is LP minus f is equal to minus of UPF, and the third one is UP minus f is equal to minus LPF.